invitation to talk about biomimicry and the work that we do. So my name is Jamie Miller. I'm the Director of Biomimicry at B+H Architects. I'm also the founder and president of Biomimicry Frontiers and the founder of Biomimicry Commons. Today, I really want to talk about the way that biomimicry is being applied and the progression that's happening in the field since it was really popularized in 1997 by Janine Benyus. We're seeing a huge upswing in companies and individuals taking on biomimicry. And I want to walk you through kind of the general principles of biomimicry, but really how it's being applied, which is, I think, the best way to describe it. The main motivation for me in all of this is the learning that we've been building as a species in a very unique way. We're unlike any other species on the planet in the way that we designed ourselves outside of nature, the way that we've been able to harness stored energy in things like fire to make new materials or new environments or engineer new products and systems that ultimately build us out of nature. What's interesting, what I find really fascinating is the design thinking, our assumptions, the way that we think about design, and how those have informed design. So early assumptions like we are separate from nature. You can see that in our buildings and our cities. We're literally creating this contrast between us and nature. We've been building under this belief that we are able to control and dictate nature, or that nature exists for our human consumption. And again, you can see that these are embodied in the way that we do design. We design buildings to resist nature. We resist 100-year storm events. We resist environmental perturbations. So the way that we think has a huge influence in the way that we design. And the way that we think is informed by these assumptions that we have for how the world works. And I think this is what's most important about today, is that we need to solve these wicked problems that we're facing, like climate change, not by necessarily trying to change our design, but most importantly, by trying to change our thinking. And this is what we're seeing. We're seeing this glaring contrast come to a halt. Nature does not like gradients. You know, imagine we all left the city today. What would naturally happen is nature would take over. We've created this contrast between the way that we do things and the rest of the natural world that is very expensive to maintain. It takes a lot of energy to fight nature, a lot of unnecessary energy to fight nature. You can see that in your lawns, how much energy you put into stopping weeds from taking over. So nature wants to grow, and it wants to grow everywhere, but we put a lot of effort into stopping that. What's interesting is that the more we create this contrast, the more we fight nature and create these two worlds, this built environment and natural environment, the greater the gradient, and therefore the greater the potential for release and reorganization. And this is what we're seeing today, is nature is starting to reorganize and release and overcome our engineered environments. I love this quote by Buzz Halling, who says that the longer one view is held beyond its time, the sharper and the more extreme is the surprise, the perception of complexity, and the resulting adjustment. So my whole belief is that we need to really think differently. We need to think naturally in order to start to build naturally, so that we can kind of level that gradient and come back into equilibrium with our environment. So this is where biomimicry comes in. I think it's one of the most valuable mindsets that we have, because it's drawing on inspiration from nature. In my mind, there is no greater model of sustainability on this planet than nature. It's been around for 3.8 billion years, figuring out how to build structures, how to adapt, how to engineer, how to do chemistry on this planet. And it does so with a really simple set of principles and really sustainable way of doing things. So biomimicry gives us this lens to go and tap into that genius, to learn from nature, so that we can bring that to our built environment and maybe adapt and change the way that we do things so that we're more in harmony with nature. And biomimicry's true potential is that it allows us to look at what everyone else is seeing, but think when nobody else has thought. I'll give you an example. 20 years ago, I would have looked at this image and said, I see some trees, some bushes, a nice little pathway, some roots. But through a biomimetic lens, all of a sudden I start to see ancient elders that have long lasted climate change. I see towers that are moving fluids up hundreds of feet without electricity, not using any mechanical devices to pump water. I see towers making solar collectors using benign manufacturing, benign chemistry, using only a subset of the periodic table of elements. It's manufacturing at body temperature and body pressure. It's not using high temperatures and high pressures to make these solar collectors. And what's amazing is these solar collectors fall to the ground into a circular economy. In this image, I see that there are no wastes. I see that there is no unemployment. I see that there are towers working together through underground networks, sharing information and resources, even with competing species, to maintain the resiliency of the overall system. I see a system that naturally strives for diversity, and in that diversity, it thrives. So through a biomimetic lens, it's simply about shifting the way that you look at the natural world to see it as a model, as a mentor, and as a measure for how to do things sustainably, how to do things more efficiently, and perhaps how to do things more beautifully. Fundamentally, biomimicry is about shifting our perception. As I said, we've been designing with these early assumptions for hundreds of years, this idea that humans are separate from nature, that we can control nature, that nature exists for our consumption. Those assumptions have been driving our designs for hundreds of years, and they've gotten us to this point where now we're seeing this massive opportunity for collapse. We're seeing things wanting to shift. And instead of trying to wipe it all out and start over, what if we could adapt our thinking and start to design from a new lens? So biomimicry is innovation that's inspired by nature. It was a term that was popularized by Janine Benyus in 1997. This is perhaps one of the most famous examples, which is Velcro. Velcro was invented in the 1940s by George de Mestral. He's a Swiss engineer who loved hiking with his dog and would go up into the mountains and constantly come back with these burrs sticking to his pants or to his dog's hair. And he took his frustration with those burrs into a fascination and started to explore them, looking at those hooking mechanisms called barbules. And those barbules were the inspiration for creating Velcro, which has become one of the most successful adhesives of our time. A company based out of Toronto emulated the bumps of a humpback whale fin to make a turbine blade that's 20% more efficient, runs at slower wind speeds, and is quieter than a traditional turbine blade. In Harare, Zimbabwe, architect Mick Pierce looked to the termite mound to design a better, more efficient Eastgate building. And so his design challenge was to build a building in Zimbabwe that does not have air conditioning. What's amazing about termite mounds is that they are these giant mounds. They can exist, 6 to 10 feet out of the land into the landscape. And that landscape can fluctuate from 40 degrees in the heat of the day to 2 degrees at night. And yet inside the termite mound, it maintains a constant temperature of 32 degrees plus or minus a degree. And it's doing so through this beautiful network of tunneling systems, pulling cold air from the earth, vacuuming it up through this stack effect, being pulled out by all these little holes that the termites make out of the mound, using the wind to create vacuums. So it does so through a very intricate circulation system. And Mick learned from these termite mounds and emulated those in his Eastgate building, which has all of these pipes and different poles to naturally draw air out through a stack effect, and a cooling mechanism that's being taken from the ground to push the hot air up and out, so that this building really maintains a constant temperature without using a lot of electricity. In fact, it saved $3.5 million on upfront costs because it didn't need the HVAC system. And it uses 10% of the energy, uses 35% less energy than a traditional building in that environment. Another really cool product is called A-Peel. And A-Peel went to one of the big problems that we have today, which is food waste. It's a multi-billion-dollar issue in Canada alone, let alone worldwide. There's so much food being wasted. And a big reason for that is shelf life, how long fruits and vegetables, fresh food can stay on a grocery store shelf. So A-Peel kind of hilariously wondered, how do we make better packaging for fresh fruit? And where they looked to was fresh fruit. Fruit, and in nature, we see this all the time. Fruit is the best example of how to make packaging. You think of a banana peel or an avocado peel. that skin provides a timed release freshness so that it decreases freshness over a longer period of time. Like when you peel it, it becomes rotten very quickly. So A-Peel has figured out a way to make another peel that is biodegradable, non-toxic, uses only benign chemistry to make a new film or a skin for fruit, which increases its shelf life and therefore reduces food waste. Another really powerful example is in the concrete industry. So if you know much about cement manufacturing and concrete, it's one of the biggest emitters of CO2, of carbon in our manufacturing industries. So we make concrete by emitting carbon. But what's so amazing about nature is that it actually uses carbon to make structures. Carbon is not a problem in nature, it's the building block. Everything in nature is built from a subset of the periodic table of elements, pretty much 6 elements, and carbon being one of them. So carbon is not a problem in nature. And in fact, the coral that you see in coral reefs, they are made from they're made from 2 ingredients, salt water and CO2. So they can make a material that's very comparable to concrete without emitting carbon, actually sequestering carbon. So many companies have figured out how to do this. Carbon Cure is one of them. But there's a research happening at Stanford that has figured out a way to actually emulate coral reefs and use CO2, combine it with salt water and the minerals in salt water to make calcium carbonate, which has a strength kind of profile similar to concrete and Portland cement. So those are just a few examples of what the world is doing, taking inspiration from nature. But there are so many other examples out there. There's so much research happening too that is just ballooning this whole science, this whole field. You know, looking at electric eels to inspire new kinds of power source. I'm studying the way that ants can build bridges with themselves to make better bridges, or learning from pine cones how to make more energy efficient buildings, looking at butterfly wings to make better solar cells. There are thousands of research projects happening in the world that are allowing us to see how nature could inform our designs for us to become more efficient, more sustainable in the way that we do things. A recent study showed that there's an expected $1.6 trillion of expected global output in biomimicry-based technologies in the next 6 years. This is a huge field. It's rapidly emerging, and we're seeing massive change taking place. Not only that, it's helping us kind of understand the brilliance of nature. This is what I find fascinating about biomimicry, is that it's this powerful tool or lens that allows you to enter into conversation with nature to help us realize really how brilliant the natural world is and how much it's really doing for us. So in a lot of my work, I'm constantly trying to speak on behalf of nature, thinking about all the ecological services that nature provides for us, and how much money that saves us. So you think of, producing oxygen, of course, producing food, but sequestering carbon. There's no greater model of carbon sequestration than nature, or dissipating storm events, or creating soils for foods and pollinating. All of these services that nature provides for us that go unchecked on our balance sheets that engineers don't account for. So when you kind of drive over that wetland, you're erasing this ecological service that is saving you millions of dollars, and then you're going to have to replace it with an engineered structure, an engineered infrastructure. So biomimicry to me is this gateway. It's a lens that once you start to look at it, you'll start to realize how much nature is doing for us and how much it's doing it for free. The thing I want to kind of mention too is that biomimicry is not a new idea. I have an Indigenous elder who I work quite closely with, has become a good friend of mine. And when we first met, I told her what I did. And after I said my spiel, she said, well, Jamie, we've been doing biomimicry for thousands of years. You think of snowshoes that were inspired by Arctic hare feet, or igloos that were inspired by polar bear dens. These are the sketches of Leonardo da Vinci, who was constantly looking to nature for design and innovation ideas. Or you think of Antonio Gaudi, who built the Familia de Grada in Barcelona, Spain, using nature as his, number one muse, like as his inspiration for how to build better columns and spirals, staircases. For me, though, my lens really shifted in a third year course when I was studying engineering. And the course was called Math and Poetry. It was an elective where we learned an hour and a half of math theorems and then an hour and a half of poems. And we kind of just unpacked them. And the professors were brilliant at having us almost believe like we were unpacking these ideas. One of the theorems was called the Fibonacci sequence, which is a sequence of numbers that when you add two numbers prior to the third, you get the third. So 0 plus 1 is 1. You add 1 plus 1, you get 2. You add 1 plus 2, you get 3. 2 plus 3, you get 5. 3 plus 5, you get 8, and so on. And the professor had us then take those numbers and start to play with the geometry. Like, what if you had a 1 by 1 box and then the 1 by 1 box? Well, you could fit the 2 by 2 box. And beside that, 3 by 3 box. And under that, the 5 by 5 box and the 8 by 8 box, and so on and so forth. And we thought that was really neat that we unpacked this kind of beautiful rectangle, which inadvertently is called the golden ratio. He then had us connect those corners of those boxes to get this spiral. And that's when kind of the whole world shifted for me, because he asked us, where have we seen that spiral before? And all of a sudden we started to realize that it's in the shape of shells, in vortices, even when you pull the plug in your bathtub. The packaging of sunflower seeds or pine cones. Like I said, that vortex. This spiral is ubiquitous in nature. It's in our skin pores, it's in our ear canals, it's in the way that the universe is expanding from Big Bang. This idea that nature's following this spiral helped me link math and science to the natural world and helped me better understand that nature's doing design, and it's doing it brilliantly. The Fibonacci sequence just helped me understand that, helped me see that brilliance in nature, helped me use math to understand what's really happening in the natural world. And that kind of set me off on this journey where I had to continue to find nature's genius. From there, I read a couple books, one called Cat's Paws and Catapults, which really explores some of those questions that got unanswered as a 5-year-old. Remember asking your parents, like, how do ants carry such large loads, or how do cats jump so high? This book kind of explored those and unpacked the engineering of it. I eventually found Janine Benyus's book in Biomimicry, Innovation Inspired by Nature. And once I read that, I realized I had to go find her and learn from her. So I went to Costa Rica to one of their excursions. This was back in 2007, and learned the deeper principles of biomimicry in the Costa Rican jungle. From there, I started to teach biomimicry at OCAD University in Toronto while doing a PhD in engineering. I became quite obsessed. I had no intention of doing PhD or any grad work, but this obsession with wanting to learn from nature grew to the point where I thought that was the only place I could do it. There weren't many people doing biomimicry. And so in my PhD, I started to explore that difference between humans and the rest of the natural world. Like, what made us so different? And I started to explore these ideas of assumptions, design thinking, paradigms. And I noticed how, things like Newtonian science helped us to compartmentalize the world into these little compartments, these silos, and then we could study the silos and learn from them. That's why we have biology and chemistry and physics and math. We're learning in these silos how to uncover and understand the natural world. But then we're able to then manipulate them and reorganize them and re-engineer them. Or this idea of individual growth, the way that humans strive for continual consumption to maximize. You think of a forest, there's no tree that's 800 feet above the rest of the trees. There's this canopy that's intact, this inherent kind of leveling out where each tree strives for its greatness, its higher potential, but it hits a plateau and then starts to distribute and share resources and information in the understory. But what's cool about that is the intact canopy actually provides a resiliency strategy, so that you can imagine if you're one tree way up in the sky, you're quite vulnerable to winds and weather. But that canopy dissipates those storm events so that the understory stays kind of stable. It doesn't get messed up. Once I did my PhD, I created my company Biomimicry Frontiers because I wanted to apply biomimicry. I wanted to take that philosophy, that thinking, that design thinking, and apply it. Think naturally, build naturally. And after starting my company, I was eventually brought into a global design firm where I became the first director of biomimicry. And since then, we've had a director of biomimicry at Microsoft. We're seeing an uptake of corporations really bringing in this new way of thinking. And I say new with quotations. So at B+H Architects and our global firm, Surbana Jurong, which is based out of Singapore, we're starting to explore design fiction. Like, let's rethink how we design our spaces. We worked with the healthcare industry to explore how do you bring light deeper into a building, knowing that natural light is very helpful for healing. How can hospitals and healthcare facilities bring that natural light in? We looked at polar bear fur, which is pretty interesting because polar bear fur is translucent. It's clear. And it actually, the skin of a polar bear is black. So that translucent fur allows the light energy to come into the black skin and warm it. So we started to play with fiber optics and how do you pull, and even insect eyes for how to maximize the light coming in and pull it in further into a building. We are exploring biomimicry at multiple levels too. This is to give you an example of how to think about biomimicry. So there's three traditional ways that we do biomimicry. It's emulating form in nature, so copying shapes. And these are impellers that are based on that Fibonacci spiral. We partnered with Jay Harmon, who invented this and applied it to indoor agriculture. There's form, there's process, which is copying how nature manufactures. And then there's systems. And systems biomimicry is the deeper principles, learning how nature behaves so that we can integrate in it in a more harmonic way. So form is quite attractive in architecture, where we're starting to play with the shapes of buildings, see if we can make them more efficient, because nature is really good at using shape to reduce the amount of materials it needs. So you can see down here that column, that white column, that's the skull of a bird. You know, you got these flat plates with these piles standing up. And architecture is using that as inspiration to reduce material use. But there's all sorts of applications where we're starting to play with form-based biomimicry. With a private client, we designed this tower that emulated the root structures of a mangrove tree. So mangroves live in really dynamic conditions. They're usually at estuaries or deltas where there's like the river water is coming into and hitting the ocean. Often in these deltas, the rivers are very dynamic, and the sediment or the sand is also dynamic. It's all very moving. So those multiple piles, those multiple roots, allow it to be more stable in that dynamic environment. We copied that because this building was in a delta. It was in a river delta. So we made this three-pillared kind of foundation. We worked with the engineers from our sister company, copying dragonfly wings to build the structure, so do the engineering. And we were able to make this spiraling pattern that reduced the material necessities and the requirements of this building. In India, as a part of my company, Biomimicry Frontiers, we were designing a house, and we wanted the house to passively cool. So one of the things about biomimicry is that you want to find the function you want to achieve. In this case, we want to cool a building. And so we just simply asked, how does nature cool? One of the organisms that we took inspiration from was an elephant. And I didn't realize this, but an elephant has these cracks that capture moisture. And so when it goes in the hot sun over a long period of time, that moisture evaporates at a slower rate because it's kind of protected. So we designed this rock wall facade that's hooked up to the rain harvesting system so that when you trickle water and it got wet and the cracks in the rocks had the same metaphor, the same functional strategy. It would passively pull the hot air from the building, evaporate the water, and keep that building cool. The process, again, is like how we copy the way nature manufactures. You think of us, we make things by using toxic chemicals, high pressures, high temperatures. If you think of nature, it builds with such a simple set of common raw materials. It uses only the energy of the sun. Everything is at water-based chemistry. It's at body temperature and body pressure. Think of a spider. A spider can make silk that has a strength to weight ratio greater than anything we've ever made as humans. And yet that spider is doing it at body temperature, body pressure. And often that spider will eat its own silk, fully biodegradable, fully recyclable. So in our practice, we've been exploring how do we copy the way that nature does things, the processes in nature. We did take inspiration from Mick Pierce and the termite mound and designed a house that had that stack effect. And we started to play with the fluid dynamics to see, like, could we maximize air circulation with only form instead of using vacuums and fans? We also looked at prairie dogs and the way that prairie dog holes have this like really cool structure where one hole is a little bit higher than the other so that it creates this like laminar flow that eventually gets sucked into the one hole, creating this circulation vacuum. We applied it to a house by understanding where the natural wind patterns were, especially in the summer, the lateral wind pressures, and then we made little forms to help suck that air in and create this vacuum. If you think of nature too, you know, trees can't go and import water. They have to find water and create water strategies for a localized situation. It's like our buildings, except our buildings are pumping water in, often from very far distances. But what if we could just like leverage and maximize the water that lands on our site? In a building, we designed a whole water strategy so that was fully off-grid, and we learned from the baobab tree, which is an African tree that has these giant trunks so that when water is scarce, it holds it almost like a camel. And you can see it's got very few leaves so that there's not a lot of evapotranspiration. And the leaves are very thick so that it can store and maintain water in them. So we learned from that tree how to store and harness. So like the buildings that we use have very low water usage and high storage, so that this building, which is in India, was able to capture the water during the monsoons, but also maintain it during the droughts. In Bengaluru, where this building is, they could have up to 100 days of drought. So you have to be able to capture all that monsoon water and then store it and use it sparingly over 100 days. And that's how we designed this house. So there's form-based biomimicry, process-based biomimicry, and the deepest and most important is systems-based biomimicry. And this is where I've applied a lot of my work at B+H and through my company Biomimicry Frontiers. We work a lot with land developers because we want to know, how do we design with a system? Our philosophy is we don't want to do less harm. That's like a cop-out. It also implies that humans are an innate and bad species, but we are nature. Our breath feeds trees, our bodies will feed the soil. Why can't our buildings feed their ecosystems? I believe that we can go beyond doing less harm and become truly regenerative, just like our bodies are. Our bodies are going to regenerate the soils and the ecosystems around us. So in systems level biomimicry, we're trying to understand those deeper secrets of nature. How does nature work? And specifically, you know, when we're in an ecosystem, where's it going to go? You know, where's that water want to go? How is the climate going to kind of influence this? What's the soil chemistry like? Because if we understand that natural trajectory of where nature is going to go, then we can place buildings in kind of situations that doesn't fight it. You know, we can work with nature. It's very expensive to fight nature. So one thing that we've done is in you know, an urban environment, we've started to just utilize nature, creating planting strategies that create more life. We use permaculture and planting strategies that enhance the overall performance of that site. And that's one way we're measuring whether we're a contribution or not. You know, if I want to do less harm, I've got to be able to prove that I'm doing less harm. And one of the ways is we measure the ecological performance of the site. So what is that site doing in terms of carbon sequestration, air pollution reduction, noise reduction, temperature regulation? What's it doing before we got there? And then once we do a design, how do we compare to that baseline? In that India house, for example, we're able to show that we are sequestering more carbon than the site was doing before we were there. We're capturing more rain in a 25-year storm event. We're reducing more air pollution in NOx, SOx, PM10, PM2.5. We're regulating the temperature better. And also, we're growing food and medicines and natural bug repellents so that this whole ecosystem that we're creating on the building is creating all of these ecological services that are helping the environment, helping that space, as well helping the humans. And the thing about permaculture is that it's a design strategy where you don't need human intervention. If you think of a forest, there are no gardeners out there, and yet all the organisms seem to have enough food. So permaculture is about creating a strategy where it doesn't take a lot of input from humans, whether that's through chemicals or pesticides or pulling weeds. It just recognizes that nature has this natural equilibrium. When you let nature be, it'll find stability. It will figure out a way to work together. So this process of working with landowners and trying to build systems that work in harmony with the land is something I call the living story. And it's a process I developed in my PhD where we use, measuring tools. We also use indigenous knowledge holders to map out what this land is doing. What does it want to do? What will it permit us to do? And what will it support us in doing? Or even like what will it inspire us to do? It's all about letting the land lead and recognizing that it's expensive to fight nature. So some of the applications that we've used this process is one in Eastern Ontario. We partnered with a off-grid prefabricated home company called Cabin, which makes these beautiful homes that are fully off-grid, that can be built in 4 days. They're affordable, and you can place them anywhere. They wanted us to build a whole community of these. So we started to map out the story of the land. What is here? We've got this wetland and healthy forest. We've got this river system. We've got areas of agriculture, community school, and the slight topography. Knowing that, we tried to figure out, okay, then how do we contribute to that space? Where can we put infrastructure in a way that's going to contribute to the land, actually add more life? And what we did is a strategy where we just used the existing farmland and we were able to make this density so that you hit your target numbers in terms of like having enough homes, but you save the forest. We recognize the forest is doing a lot for us, and it became the backyard of all of these little patches, so that it became this shared amenity, so that the whole community could use the forest as their backyard or as their play space. The clusters were inspired by ants and the way that ants are very resilient despite not having a hierarchical structure. There's no leadership in an ant colony, and yet they're super resilient. And their resiliency comes from their ability to communicate with each other. They use pheromones, they use smells, but also when they pass each other, they touch their antennae to quickly give a check-in of what's happening. So what we did is we made these clusters of cabins. There's a bunch of clusters you can kind of see. And the clusters allow that little community to share resources. So it's producing way more energy than they all need. So there's a battery bank. It's also collecting enough water for all their needs so that there's a decentralized water system. And all the wastes are being treated. And the clusters are centered around this like shared amenity space so that, the cluster can decide how they want to use that. It could be an outdoor oven. It could be a bunch of planters for growing food. It could be a play space, depending on what the needs are of that cluster. But the clusters are also interconnected to other clusters. And there's this kind of ribbon connecting them all so that when you go to your other clusters, you can kind of touch in with your neighbors. You have those collision points where you're chatting and saying hi and how are things going. The clusters are more tight-knit. They're like villages. And they're based on this belief that, the most resilient and happy places are those that you have a deep connection with your neighbors. There's a study that shows above 150 people, you start to lose that connection because it's just too many people to think about. But under 150 in a village, you kind of know what's going on. Like, hey, Jim's kind of sick right now, and maybe we should bring him some soup or help him out. and you have, the capacity to go and help. But once you get to huge numbers, it's like there's just too many people. You can't think of everyone. You can't help everyone. So the cluster was based on that philosophy of creating these resilient little villages, but a network of villages. So you're still connected to the other people, but just not as intimately. And so this design has been passing through approvals, and it looks like it should be built in the next year or two. Another example of using the living story is in near Creemore in Collingwood in New Lowell, Ontario. And here, when we're mapping out the story of the place, we recognize that the Minisig wetland, which is one of Ontario's most important wetlands, has all these tributaries running to them that are being severed by roads and infrastructure. And in fact, our site was home to this really beautiful network of tributaries. And when we went to the site, those tributaries are being totally washed away from agriculture, from tiling, from roads. So in our design, we wanted to let that water lead. We wanted to actually enhance it rather than bury it, because water especially will dictate whether your design is a success or not. So we built our patches, our model based on those river systems. We created a way to actually enhance them so that all the water management is leveraging and utilizing those tributaries. And we actually won an international award for this design for its sustainability mindset. What's amazing too is that this living story is allowing us to connect more with Indigenous communities. I think it's a language that naturally bridges Indigenous knowledge with and allows us kind of engage with them. So one of our clients is Métis Nation of Alberta, and they have this massive infrastructure project in Alberta where they're creating a Métis crossing, which is a cultural gathering center in just north of Edmonton in Alberta. And they have buildings going up. They brought back bison, these huge bison paddocks with white bison, with white elk, with horses. And it's a space for the Métis to celebrate their heritage, to come together, to have a home once again, and showcase to the world, their ingenuity, their resiliency, and their culture. It's a place for Métis people, but also for the rest of the world to learn about the Métis and their true importance in Canadian history. So in their living story, we saw things like these beautiful water ribbons that went on the inside of the meander of the river. We really explored the water. Again, water is a major storyteller. It'll dictate how a landform will be created. And then when we learned this living story, we were working with the Indigenous elders, learning about their stories and helping the architects put the infrastructure in the right spots so that it wouldn't flood, for example. We helped them move a building out of a flood zone because we understood that overland flow. And finally, this Indigenous relationship building has been really accentuated in this project in Kauai, which is in Hawaii. Kauai is, we're hired by the Kauai Federal Credit Union, which is a bank, and they wanted to build this building called the Economic Resiliency Center. And they're inspired by biomimicry and our process and asked me to come down and start to engage in the living story. But what I recognize is that I'm not from Kauai, I'm not Indigenous to Kauai, and I don't know the land. So if I want to learn the land in a short amount of time, I had to talk to those people who have the longest relationship with it. So we went on this year-long engagement with the Indigenous people of Kauai and built this living story. We learned their history and some of their traditions. We learned about their philosophy of how to live on a land, because if you think about it, Kauai is in the middle of the ocean. It's a volcano in the middle of the ocean. It's one of the most difficult places to live, and yet the Indigenous Hawaiians have lived there for 2,000 years quite successfully and have built abundance and have survived and thrived on these dynamic islands. So what are their secrets? And that was a part of our process, is to learn these secrets. We also mapped out the ecological assets. Nature's doing a lot for us. So we looked at the coral reef to the east of the building and the wetlands to the west, and identified that those are a part of our design process about how do we enhance those things. because they will save your building. They are part of your resiliency strategy. So if you don't take care of them, well, then you're not going to survive. So our building is not just the building, it's about building for the whole ecosystem. So what's amazing is that biomimicry has, all of these different applications. You can copy forms, you can copy processes, but it's mostly about building this relationship. It's about acknowledging nature's genius. And anytime you have a challenge, it's a design challenge, a business challenge, an art challenge, whatever it is, just ask yourself, how would nature do it? And look to local genius. This is what I love about my design, is that, say I want to build a tower that has this dynamic facade or can handle cold and heat. I just look to organisms in my environment that do exactly that. How does nature manage cold and heat? The local genius is the guide. Because if you want to know how to design in a space, talk to the elders who have been doing it for thousands or millions of years or billions of years. So like I said, there's a massive emergence of biomimicry happening at multiple levels. A lot of people feel like it's, you have to be a biology expert or you have to be in a lab, but you don't. You can create your own biomimetic career no matter where you are. And that's actually the inspiration for why I created the Biomimicry Commons. The Commons is an education and incubator space for you to bring biomimicry to your world, whatever it is you're doing. I've worked with bankers, architects, engineers, artists, students, parents, you name it, we've done it. And we found a way to bring biomimicry into your business. I truly believe that whatever challenge you have, nature has a potential solution. You just have to learn how to see it and how to abstract it. And it's not hard. I dropped out of biology in grade 10 because I hated biology. So you don't need to be a biologist. We have a way of teaching you to leverage your own genius. You have your own skill set, you have your own perspective, and that perspective is rich in how it relates to nature. Nature will tell you secrets when you engage it. And the Biomimicry Commons is a bunch of courses and workshops and excursions that help you do that. So I want to encourage people to bring biomimicry to their business. I want to build more director biomimicries. I want more people changing their companies and their landscape. Because I think, we have so much to learn. When I met Janine Benyus back in 2007, I was, at a point where I was like pretty disillusioned and I didn't really like what humans were doing to the planet. But she said to me, and I'll never forget, she said, you have to remember that we're not a bad species. We're just a very young one. And that's stuck with me ever since, that we have this opportunity to quiet our own cleverness, to learn from this genius, and learn how to, again, fit into this place that we call home. Thank you very much.